Hello everyone, I am Carrie Rasmussen, a food safety specialist at Commercial Food Sanitation. Welcome to our online course on hygienic design. In this module, we will look at utilities from a food safety perspective. Our learning objectives are to understand the risks from utilities, including air, water, and steam in our manufacturing plants and the corresponding control measures. Air, water, and steam are commonly used in food production facilities. Sometimes utilities are an afterthought and we forget how important these are to food safety. We need to understand that utilities do introduce risk, and to reduce the risk, we need to consider proper controls such as filtration to ensure product quality and food safety. Hygienic design principles should also be applied to utility systems. Air, water, and steam should be added to the food safety plan at the plant and should be assessed from three perspectives. First, microbial risks, which need to be considered for water and air. Steam rarely has microbial risks due to the temperature. Second, physical hazards, which may be introduced from the supply or from the components used in the system. These risks can be reduced through filtration and proper selection of materials. Third, chemical hazards should be assessed, using testing of water to help understand the risks. With steam, the chemicals used for boiler operation need to be approved for use in a food facility. Generally speaking, different products face different levels of risk. Therefore, we must first clarify what is the risk level corresponding to the products being produced. Is the risk high, medium, or low? After this assessment, we must incorporate control measures to ensure the products are properly protected. For air, water, and steam, we often use filters to filter out different particles. When choosing the filter, we need to consider flow rate, the filtration efficiency that we want to achieve, and the size of the particles that we want to filter out. Clarifying these parameters will help us choose the right filter and effectively remove the contaminants that we are targeting. Now, let's take a look at control measures for environmental air. Why do we care about air quality in the production and processing environment? First, air quality is important for creating a comfortable and safe working environment for employees. People safety should always come first, and pollutants such as dust should be removed by using proper filtration. Second, we reduce the risk of environmental contamination to the product. Third, air quality can impact the shelf life of the product. If there are spoilage bacteria in the air, such as yeast and mold, these could contaminate the product, which would decrease the quality of the product and shorten the shelf life. Fourth, if there are air pollutants that will affect the quality of the product during a production run, the line may need to be shut down more frequently for cleaning, which affects efficiencies of the production line. When choosing the efficiency of the heating, ventilation, and air conditioning units for process facilities, we need to know who the enemy is and how big they are. We can then select the corresponding filter specification. On this slide, you can see the different filtration levels corresponding to different particle sizes. Air handling systems have multiple filters. Primary and secondary filters act to protect and remove coarse contaminants in the air, allowing the final filter to be more effective. The effectiveness of the air filter should be verified through sampling and testing. In addition to the air filters, the air in the production area must follow a certain flow direction. As shown in the figure, we must ensure that air flows from high hygiene areas to lower hygiene areas to avoid cross-contamination. This requires air handling systems and separation practices to maintain positive pressure from higher care areas to lower care areas. Where positive air pressure has been installed as a control, this should be monitored to verify that positive pressure is being maintained. Room condition parameters are dictated by the type of product being manufactured and the product sensitivity. Lower temperatures help control the growth of microorganisms in the environment. Some products require specific temperatures to achieve the desired product quality and functionality. Humidity controls room condensation, which is an adulterant if it falls onto product. Humidity can also affect the quality and functionality of the product being produced. Air exchanges help control both condensation and microgrowth, as air is pulled through conditioning units at a proper frequency. The plant should have established ranges and targets set for the specific products that are being produced. The facility needs to monitor and document the conditions. In some cases, a continuously monitoring system may be used, which will alarm if conditions exceed the set range. Compressed air is used in many applications in food manufacturing, including bagging, packaging dispensers, air guns, mixing, and drying, to name a few. For compressed air that may come into contact with product, the filtering requirements are generally recommended to be filtered to 0.01 microns or less. Compressed air can become contaminated from different sources. One is environmental air, where water vapor, microorganisms, or dirt can be introduced. The air compressor can introduce contaminants such as water or oil. Finally, the air receiver and distribution piping can deteriorate over time and contaminate compressed air with rust or pipe scale. To remove contamination from compressed air, multiple filters should be in place. Particulate filters remove solid particles. The coalescing filter removes oil and water. The final filter is the last protection before the air comes into contact with product, so this filter should be installed as close to the point of use as possible. Now we will look at water controls in the plant. Water-related microbial risks are broken down into these three categories: bacteria, such as E. coli, protozoa, such as Giardia, and viruses, such as rotavirus. How do we manage risks from water? First, we need to be aware of the source of our manufacturing plant water. Are we using municipal or well water? Whichever source is used, the water needs to meet local laws and regulations. We need to identify and address the corresponding risks according to these different water sources. Second, we need to understand what the water is being used for and the level of risk to the product. If water needs to be treated to reduce a risk, systems such as reverse osmosis, UV light, filtration, and approved chemicals should be in place. Lastly, the design of the water piping system should be considered. Backflow prevention devices should be in place. There should not be any dead ends in the system where water can sit stagnant and become a source of contamination. Water should be routinely tested to ensure it meets micro requirements as well as chemical requirements. Testing of free chlorine should be conducted as needed. Sampling and testing points should be rotated within the plant and should include hand wash stations, hoses, and drinking fountains. Finally, we'll take a look at how steam is managed at the plant. Steam is often used in food manufacturing to heat products. The steam may directly come into contact with the product or may be used indirectly. Steam may be used for sterilization of packaging materials, such as bottles prior to filling. Steam is also used to generate hot water for cleaning. Different products and manufacturing facilities have different steam purity requirements. In the food industry, we often use filtered steam, which is also called culinary steam. If a product requires higher purity, clean steam can be used. In boilers, different chemicals are used for the purpose of softening water, descaling, and preventing rust. When steam is being generated for food manufacturing use, the chemicals need to be managed according to the laws and regulations for the food industry. Steam generation systems should include a sampling valve, as sampling and testing is required. The steam generating equipment and piping need to be manufactured using corrosion-resistant materials, such as 300 series stainless steel. A separator should be installed to remove particles 30 microns prior to the injection heater. A condensate trap is located downstream from the separator. Further down the line, a stainless steel 5-micron culinary steam filter should be in place. Lastly, a sanitary check valve should be installed if steam injection is submerged in the product. Depending on the source of the water and the steam generating system, there may be sources of contaminants. Poor feed water, condensate carryover, and the improper use and selection of chemicals can cause steam contamination. Sampling and testing the steam condensate is necessary to ensure the steam meets the expected standards. Steam should be evaluated based on off odors or flavors and turbidity. The sampling location should be as close to the process application as possible, and results should be documented. In summary, utilities are commonly used in the food industry and are often in direct contact with the product and primary packaging materials. We need to design and maintain utility systems correctly to ensure they are clean. Utilities can be a source of contamination when they are not designed, installed, and operated properly. Routine maintenance, periodic testing, and cleaning are critical to prevent contamination. Thank you for watching. If you have any questions or would like more information, please contact us at training@cf-san.com or visit us on our website at www.commercialfoodsanitation.com.